We're going to show you how to graph the equation f of x equals x squared plus 1 over x minus 1. First, we're going to find the vertical asymptote. We will do this by setting the denominator equal to 0. So we get x equals 1. Now that we have the vertical asymptote, we can write the domain, which will be negative infinity to 1 and 1 to infinity. Now we will look for the horizontal asymptote, but because the equation is top-heavy by 1 degree, there is no horizontal asymptote. But there is a slant asymptote. We can find this by dividing the numerator and the denominator. And we will end up getting x plus 1.
So next we're going to talk about the symmetry of our function. So a function can either be even Steven, odd Todd, or neither Nigel. So we're going to determine the symmetry by plugging in f of 1 and f of negative 1 into our function. If we're plugging in 1, we're going to get undefined because we already know that there's an asymptote there. And if we're plugging in f of negative 1, we're going to get 2 over negative 2, which is equal to negative 1. So because undefined and negative 1 don't match up, we know that this function is neither Nigel. So next we're going to talk about the intercepts. So to find the y-intercept, you're going to plug in 0 for x, so 0 squared plus 1 and 0 minus 1. That's going to come out to negative 1. So we know that 0, comma, negative 1 is a point on our graph. In x, you're going to take the top part of the equation, and you're going to set it equal to 0. And because you end up getting an imaginary number, we know that there are no x-intercepts. So to find increasing and decreasing portions of our function, we're going to find the derivative of our function, which we need to use the quotient rule for this. So the top is 2x, the derivative, and the bottom is just 1. And when you set up the quotient rule, it's going to end up being x squared minus 2x minus 1 over x minus 1 squared. And then we're going to take the top portion, and we're going to set it equal to 0 to find the min and max. Because this can't factor, we'll use the quadratic equation, and you're going to get x equals negative 0.414 and x equals 2.414. So using these points, we're going to set up a number line. So negative 0.414 and 2.414, and we're going to test numbers from each section. So by testing numbers from each section, this section was positive, so we know the graph is increasing. This section is negative, so we know the graph is decreasing. And past 2.414, we know it is increasing because the number we tested was positive. Just by looking, we can determine which are the min and max. So it's increasing until a very point, and then it starts decreasing. So we know that negative 0.414 is a max. And we know that when it's decreasing and then it gets to its lowest point, it starts increasing. We know that 2.414 is a min.
So now we will find the inflection points. To do this, we'll take the second derivative, which is 4 over x minus 3 squared. Then we will set that equal to 0. Since 4 doesn't equal 0, that does not exist, so there are no inflection points. Now we can find the concavity. Although there are no inflection points, we can plug in the vertical asymptote at 1 because the concavity often changes when there's a vertical asymptote. So we can try the numbers 2 and negative 1. When we plug in negative 1, we will get negative 8. And when we plug in 2, we will get 4. This means it will concave down from negative infinity to 1 and concave up from 1 to infinity.
Okay, so now we're ready to start graphing. So here's all our information. First, I'm going to graph the asymptotes in green. Now that we have our asymptotes in green, I'm going to put in our y-intercept at -1. Then in purple, I'm going to do our max and our min. Now that I've added max and min, it's time to start graphing. So the graph is going to concave down until we get to x equals 1, so we know it's going to face down like a frowny face. It's also increasing until it hits negative 0.414. So we're going to increase while concaving down. We're going to hit 0.414. And then we're going to start turning down because that's where it starts decreasing. And we're going to go through x at -1. And we're going to go right along this asymptote here. Now past -1, we're going to be concaving up like a smiley face. So we're still decreasing until we hit 2.414 and we're concaving up. So I'm just going to come along down this asymptote. And once we hit about 2.414, we're going to start concaving up and we're going to start increasing.
Now that we have the graph, we can find the end behavior. The limit of the function as x approaches infinity is infinity since it is increasing, and the limit of the function as x approaches negative infinity is negative infinity since the function is decreasing as it approaches negative infinity.
So this is our graph. And this is Desmos' graph with the same colors. And of course, on every graph, you can't forget the final touches.